What is PDE? A PDE, partial differential equation, is a type of mathematical equation that involves partial derivatives of an unknown multivariable function. It describes how the function changes with respect to more than one independent variable. Partial differential equation is an equation that contains an unknown function u, which is a function of x1, x2 to xn. x1, x2 to xn are independent variables. A partial differential equation is an equation that contains partial derivatives of u with respect to those variables. Example, the heat equation del u del t equal alpha del 2u del x2. Here u is a function of x and t, which is the temperature at position x and time t. Alpha is a constant, which is thermal diffusivity. The equation relates the change in temperature over time to its spatial curvature. Classification. PDEs are generally classified as elliptic, example Laplace equation, parabolic, example heat equation, hyperbolic, example wave equation. General form of a second order linear partial differential equation in two variables. A, which is a function of xy, del 2u del x2 plus twice b del 2 del x del y plus c del 2 del y2 plus lower order terms equals 0. We classify this partial differential equation based on the discriminant d equal b square minus ac. The PDE is elliptic if d less than 0. Example is Laplace equation. Its behavior is smooth solutions, boundary value problems. PDE is parabolic if t equals to 0. Example is heat equation, and typical behavior is diffusion-like behavior. The PDE is hyperbolic if d greater than 0. Example wave equation. Typical behavior is wave-like solutions. Laplace equation is del 2u del x2 plus del 2u del y2 equals 0. Heat equation is del u del t equal alpha del 2u del x2. Wave equation is del 2u del t2 equal c square del 2u del x2. Order and degree of a PDE. The order of a partial differential equation is the highest order of partial derivative present in the equation. Example, del 2 del x2 plus del u del y equals to 0. Here the highest order derivative is del 2u del x2. So order is 2. Degree of a PDE. The degree is the highest power of the highest order derivative after the equation is made polynomial in derivatives. Example, del 2 del x2 whole cube plus del u del y whole square equals 0. Here highest order derivative is del 2 del x2 and the power of this highest order is 3. So the degree is 3. Important. If the PDE is not already polynomial in its partial derivatives, you must first simplify it to that form to define the degree. Non-polynomial example. Square root of del 2u del x2 plus del u del y equals 0. This is not polynomial in derivatives. degree is undefined. Let us make this PDE in polynomial form. Square root of del 2u del x2 equal minus del u del y. Let us square both sides. Then in the left hand side del 2u del x2 and in right hand side del u del y whole square. Here the highest order derivative is del 2u del x2 and the power of this highest order derivative is 1. So the degree of this polynomial, degree of this PDE is 1. Applications of PDE in physics. Heat conduction. Heat equation is del U del T equal alpha del U del x2. Wave propagation. Wave equation is del 2u del T2 equals c square del 2u del x2. In engineering, stress analysis, elasticity, fluid dynamics, Navier-Stokes equations. In finance, option pricing, Black-Scholes equation. In biology, population dynamics, reaction diffusion models. Neuroscience, Hodgkin-Huxley model. In environmental science, pollutant dispersion in air or water. Climate modeling using PDE systems. Thanks for watching. If you have any question, please drop in the comment box.